Hi, Michelle Glass here. Welcome back to another episode in Chapter 26, Lecture 26. We are finishing up our nephron by looking at the fluid, the urine that gets dumped into the collecting duct. There is a little bit of reabsorption and secretion that can happen here. You can see the continuation of facultative water reabsorption if ADH has been released. You also can see continued reabsorption of sodium in the presence of aldosterone. In addition to that, both bicarbonate ion and urea can be reabsorbed at the collecting duct, and then the secretion of either hydrogen ion or bicarbonate ion, depending on the pH, can happen here. Okay, so looking at our collecting tube, we still see that this is lined with our simple cuboidal cells, and we can see that the collecting duct is going to be dumping into the papillary duct. If you have the presence of aldosterone, you can continue the selective reabsorption of sodium. So again, this is a sodium-potassium exchange pump. So sodium is being pumped back into the body, being reabsorbed by the bloodstream, and potassium is being lost here. You can continue the facultative water reabsorption at the collecting duct in the presence of the antidiuretic hormone. So it's the same story. We're going to see these cells making, again, those aquaporin channels so that the water can be reabsorbed. If you do not have antidiuretic hormone, then you do not get facultative water reabsorption, and instead that water is secreted, forming a dilute urine. Depending on your pH, you're going to see the reabsorption and secretion of the hydrogen and bicarbonate ions. So when you have a low pH, meaning that the peritubular fluid is too acidic, we will see hydrogen ion being secreted and bicarbonate ion being reabsorbed. So that bicarbonate ion is going to be an important buffer, helping to trap any extra hydrogen. Plus also we are secreting extra hydrogen here. If your pH is elevated in the peritubular fluid, so meaning you have a basic pH, then we see the reverse. So now we're getting rid of the bicarbonate ion and we are exchanging it for hydrogen ion, which will of course decrease our pH. We see that throughout the movements in our nephron, the urea has not been able to be reabsorbed, and so it is going to become fairly concentrated as we move towards the distal portion of the collecting tube. As it makes its way to the papillary duct, we can see some reabsorption of urea here. It's moving into that peritubular fluid, and it's going to be important in helping to regulate the medullary osmotic gradient. And that is it for now.